Alright, welcome to 7.2 Properties of Parallelograms. So a parallelogram is a quadrilateral. Alright, so first piece, right? Quadrilateral has four sides. And this parallelogram has some specific properties. We'll go over a couple of them. And one property is opposite sides are parallel. So here's a quadrilateral. The opposite sides, so QP and QP and RS are opposite sides. They are parallel. QR and PS are opposite sides and they are parallel, hence a parallelogram. Alright, so a couple other properties that come with that. So if this is in fact a parallelogram where the opposite sides are parallel, then a couple other things happen too. Then the opposite sides are also going to be congruent, and this is called the parallel opposite side theorem. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. And we're going to use this in some proofs that we write in this section here too. So if it's a parallelogram, the opposite sides are parallel. If it's a parallelogram, then the opposite sides are also congruent. And if it's a parallelogram, then the opposite angles are congruent. So P and R are opposite angles, they are congruent. Q and S are opposite angles, and they are congruent. Okay, so just remember, if this is a parallelogram, a couple other pieces here, then if you look at this as, let me just try to draw this as straight as possible. If I extend this QR out this way, and I extend QP out this way, or PS this way, and I extend QP out this way, what I'm trying to get you to see here is that, this goes back to our alternate interior angles, alternate exterior angles, same side exterior, same side interior. These two, right, since these are parallel, QP is the transversal of RS, QR, and PS. And if this is the transversal, then P and Q, angle P and Q here, are same side interior angles, which means that they both are 180 degrees. They're both supplementary. Right? So another one that's going to come up very soon. So parallel lines, right? So in parallel lines cut by a transversal, there'll be some same side interior angles, or however we want to draw it, they're going to be 180 degrees. There's alternate interior angles, there's alternate exterior angles. So that's all going to come into play again as we start going through these proofs, right? So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent if it's a parallelogram. If the quadrilateral is a parallelogram, then one of those three things come up to be. Alright, let's take a look at the problem. Alright, so here's one that you'll see. Find the values of x and y. Alright, so we got sides AB and side DC. So AB is opposite DC, so AB is equal to DC here, right? Because they're both congruent, so they're equal to each other. Therefore, x plus 4, which is AB, is equal to 12. Subtract 4 from both sides, and we got x is equal to 8, and that's how we solve for x. Y, even easier. Opposite angles are congruent, so y is equal to 65 degrees, nothing more there. This one's not in your notes, but I want to just throw one more example in similar to that one. Again, find the values of x and y. In this case, solving for y, sides QP is equal to side RS, right, because opposite sides are congruent. So 20 equals 3y minus 1, and then we solve. And we add 1 to both sides. We got 21 is equal to 3y. Divide both sides by 3, and we get y is equal to 7. All right, with the sides. The angles, angle P is congruent to angle R. So angle P is equal to angle R here, because they are congruent. Congruent implies equality, right? And then we could say that 2x is equal to 54. So x is equal to 27. Alright, so just another quick example to show you how that could come into play. Alright, and this is what I was explaining before on top here. It says the parallel consecutive angle theorem. Again, if you have a pair of parallel lines, QR, PS, whatever, you draw a transversal, right? So QR, PS would be these two lines that are parallel, and then QP would be my transversal here. Then these angles here, I'll call this angle 1 and angle 2 here, are on the same side, interior, and we saw before that these two together are going to equal 180 degrees, right? And that's what this is saying here. So x and y will equal 180 degrees. If this is x, we saw this before, this is x, this is y, the opposite angles are congruent. So x and y here are 180 degrees, right? So these two angles are 180 degrees, whether you look at them in this manner or you look at them in this manner, right? Going across. So vertically or horizontally, because you have those parallel lines on both sides. All right, so another characteristic of a parallelogram. And here's another one. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So when you draw the diagonals, this is going to be the midpoint of QS, right? So QM and MS are going to equal each other. And this will be the midpoint of PR, where PM and MR will equal each other. The diagonals are not congruent, right? They're not the same, obviously. One's longer than the other. But they do, but this point M here, the intersection of the diagonals, bisect the two diagonals individually. All right, so let's see what happens here. All right, so let's write a proof here. We're going to prove that angle B is equal or congruent to angle F here. All right, let's see what we got. So try to prove angle B is congruent to F here. Okay, so given ABCD, so ABCD is a parallelogram, and GDFE is also a parallelogram. All right, so I'm going to label some stuff here. So if this is a parallelogram, then I know this angle is congruent to this angle, and I know this angle is congruent to that angle. Okay, I know. And then the other one, and I'll say, one more here. So I'll do two here. Okay, so 1 and 1, 2 and 2. Then I also know that angle D here, 1, 2, 3 here, 1, 2, 3 is congruent to 1, 2, 3 here, and E is going to be congruent to this, do 4 here, and I know those two are congruent. Okay, cool. So opposite angles are congruent. Opposite sides are congruent, so I know these two are congruent, these two congruent, and so on and so on. I don't know if I'm going to need the sides here because I'm really just trying to prove the angles are congruent. So let me see if I get away with not even mentioning the sides. So angle B is congruent to angle CDA. Okay, so notice I called this one angle B, and then this one I called CDA. I can't just call it angle D because this angle D kind of has 4 angles here. There's one angle here, 3 and 4 here, right? So I could look at angle D going in any one of those, right? Is it this angle D or this angle D? So we gotta be a little more specific when we say angle D, which is why I use 3 letters here, right? So angle B is congruent to CDA. Okay, so we said that before. We labeled it. We said that was the definition of a parallelogram, right? So in my parallel opposite angles theorem, so in one of my definitions, one of my characteristics, if a quadrilateral is a parallelogram, then the opposite sides are congruent or equal. So we got that, and that's the parallel opposite angle theorem. Cool. And then it says EDG, which is this one, is congruent to this one here. So let me clean this up a little bit. Okay, so a lot of information here. We know some pieces here. I'm just going to go with what I have here so far. So angle B is congruent to here, and then EDG, which is this one, EDG is congruent to angle F. Okay, and we know C is congruent to A and E is congruent to G, right? But we don't need those yet. All right, so then it says CDA is congruent to EDG. So it's saying this angle here, CDA, is congruent to EDG. So it's saying, you know what? These two angles are congruent, and that's true because what kind of angles are these? And if you notice, these are vertical angles. Okay, so all vertical angles are congruent. Cool. All right, so now we got this is congruent. So if these two are congruent, then let me see. If B is congruent to CDA and CDA is congruent to EDG, then B must be congruent to EDG as well. So B is congruent to, so here's B congruent to CDA, and here's CDA congruent to EDG. So I could say angle B is congruent to angle, try to go there, green here. Angle EDG, right? And this is just the transitive property. So now I got B, so now I got all 3 of these, 1, 2, and 3 are congruent. And now, again, I'm trying to get B is congruent to F, so I'm trying to get this angle is congruent to this angle. And then my other given here says, well, EDG, so B is congruent to EDG, EDG is congruent to F. So again, I'm going to use the same property here, so angle B is congruent to angle F, and that's going to be with the transitive property again. And we could do this and then I got my proof there, check. So we could do this in 5 steps. Alright, so the next one, we're going to find the coordinates of the intersection of the diagonals. You could do this one with, I put a little graph here. You could do this with a graph. You don't have to do a graph. So the intersection of the diagonals here. So you have 4 coordinates, and the way this is labeled L, M, and O. So this is going to be like L, M, N, O is the way it's going to be, right? So it goes in a clockwise or counterclockwise, and then you know that L and M are consecutive. L and N are what makes the diagonal. So L and N make the diagonal here, right? So when I look at L and N, all I need to do is really find the midpoint of L and N. So again, you could, if you want to, you can draw these out, and so you can see that, verify that, and I'll do that for you guys as well. But here's 1, 4. Here's L, 7, 4, 2, 3, 6, 7, 7, 4. Here's M, okay, 6, 0. Here's N, and 0, 0. Here's O. So just to show you, L, M, N, O. Right? I mean, my diagram was a little different from what they have, but it is consecutive. So you could do this with or without the diagram. It doesn't matter, okay? But notice that they are consecutive, and recognize that L and N are your diagonals. So when it's asking for the intersection of the diagonals, you just need the midpoint, right? Because they intersect at the midpoint here. So all I need to do here is find the midpoint of my diagonals here. So midpoint. So I'm going to use L, which is 1, 4, not M, and N, which is 6, 0. So to find my midpoint, I'm going to add my x's and divide by 2. That's going to be the first coordinate. Then I'll add my y's and divide by 2. All right, and it should work for whether you choose L and N or M and O. It should be the same exact difference here. So if I do this, I get 1 plus 6 divided by 2. There's my x's. And then 4 plus 0 divided by 2. And when I do this, I get 3.5. 1 plus 6 is 7. 7 divided by 2 is 3.5. 4 plus 0 is 4. 4 divided by 2 is 2. All right, so that confirms that. And again, I'll do this real quick with M and O. All right, if I do with M and O, then I would have had 7 plus 0 divided by 2 and 4 plus 0 divided by 2, which ultimately gives me 3.5 and 2. All right, so the intersection of the diagonal is 3.5, 2. Again, you want to draw this out for yourself, give yourself a little rough shape, rough sketch to make sure you know which ones are the diagonals. No big deal, but it's always going to be, those two and these two. That will be the diagonals here. For this next one, you're looking to create a parallelogram here, and this could work a couple different ways, but I would definitely suggest drawing this one out. So let's get these coordinates in. I got -1, -3. So here's -1. Here's -3, so there's W. I got x, which is -3, 2. So -3, 1, 2, 3, 1, 2. There's x. I got z, which is 4. There's a y coordinate somewhere, So wx, connect, X and Y connect, and then W and Z, Y and Z connect, and Z goes to, and Z is at 4 or negative 4. So 1, 2, 3, 4, 1, 2, 3, 4. 4, negative 4, and there's Z, right? So when I'm drawing this out, and I'll connect these, right? No, W goes to X, X will go to Y, wherever that is, Y will go to Z, and then Z will go back to W, and complete, right? And just go around and around and around. So I'm trying to figure out where Y is. So I know it has to be the same size, so when I put Y somewhere, I gotta make sure that, X and Y, XY and WZ will be the same size. I need to make sure that XW and YZ are the same size. So you could figure out that the distances of YZ, and you can kind of use the slope here too to help you, right? So to get from Y to X, or W to X, right? So to get from W to X here, I'm gonna use my slope here to help me figure that out. And how do I get there? So here, I'm gonna go 1, 2, and then left 2, and then 1, 2, 3, 4, 5. So this is left 2 and up 5 if I'm going down, or down 5 and right 2. So I need to make sure the same thing's happening from this coordinate here to when I get to my next one. So if I kind of follow that same pattern here, if I go left 2 and up 5, I should get W, I should be able to get Y that way too. So let's check this out. So I go 1, 2, and then up 5. 1, 2, 3, 4, 5. So this should be Y here, right? So, and by doing that, I made sure that these two are going to be, XW, which is going to have a slope of, the slope of XW is going to be negative 5 over 2. And when I connect, and I'll do this one here in pink here, and when I connect YZ, I also need to make sure I have a slope of negative 5 over 2, which I do, right? This was the negative 5, and this was the 2 piece here. So now XW and YZ both have the same slope. And I did it from the same endpoint here, W, right? So from W I went left 2, up 5, that got me to X. From Z I need to go left 2 and up 5, and that gets me to Y here. And then I can finish this off and connect that last piece here. And just to make sure I can verify that they're the same lengths, well, X and W and Y, XW and YZ will have the same length, right? Because if I did the Pythagorean theorem, for either one of them, I did a squared plus b squared equals c squared, they're both going to have, here's my right triangle that I created. They're both going to have an a value of negative 5 and a b value of 2. So when I plug that in, they're both going to have the same. And then if I verify this one, this is 1, 2, 3, 4, 5, and then 1. So if I did on that one, so for X and Y, this is going to be 1, 2, 3, 4, 5, and 1. Right, those two are going to be the same here too. They're, that's going to be an a value of 5 and a b value of negative 1, or vice versa, but it will still get me the same c. So the slopes are the same, rise over 1, so rise is negative 1, rise is 5, and they both have the same slope, and because they have the same a value and b value, when I create these triangles, they'll both have the same distance as well. So your coordinates for y are right here at 1, 2, comma 1. All right, I'm going to throw one more example in here so you guys can look at this one. All right, so D is negative 1, 4. So 1, 2, 3, 4. Here's D. E is 2, 3. 1, 2, 1, 2, 3. Here's E. F is 4, 2, negative 2. 1, 2, 3, 4. 1, 2. Here's F. And then find the coordinates. So just draw a line to connect all these. Keep this a little thinner. And here we go. 1, 2. Okay, so now I need to find vertex G. So D goes to E, D goes to F, F goes to G. Okay, so I need to make sure that the way that F goes to G is in the same manner that D goes to E. Alright, so how does D go to how does D go to E? Well, it goes 1, 2, 3 to the right, and 1 down. So I need to make sure I get there the same way. So I'm not going to go 3 right and 1 down because that'll bring me here. I'm going to go 3 left, 1, 2, 3, and 1 up. Right, because I need to make sure the rise and the run are the same. So the run is 3 on both these, and the rise is 1. So now, if that's my new coordinate here, that's my new coordinate here of G, and I'm just going to connect these lines and make sure. It's a little bigger than I wanted. Hold on. So when I go to G here, and then from G to D, I'll see that, yeah, this is my parallelogram. So my slope here is down 1, right 3, or my run is 3. I make my right triangle here. My run is 3. My rise is 1. So in this case, in this triangle here, A is 3, and B is 1. So when I try to do Pythagorean theorem here, I'll get this, I'll do A squared plus B squared equals C squared, and I'll be able to find C. And here, in this triangle, again, my run is 3 and my rise is -1 as well. So my A value, again, will be the same thing. A can be 3 and B can be 1 because I made another right triangle here. And when I find C, I'll get the same exact C value. So both these have the same slope. Both these will have the same distance. And if I verify the same with D, G, and E, F, you'll see the same thing's going to happen. You'll have the same slope. And once you have the rise and run, are the same, it's pretty much the triangle you're going to create to find the distance formula, or if you want to use the distance formula, you do it that way also, but I probably would recommend the Pythagorean theorem here, but you'll have the same A value and B value for both of those, so you will get the same C, which is the distance of DE and GF, or DG and EF. Alright, so that's the end of 7.2. Catch you on 7.3.